Okay, fifth time trying to record this video. I'm not even saying hello anymore. I'm just letting things interrupt me. So I'm not going to go into why I had to record 5 times. However, let's go into it. So um, I'm recording this because I don't do so well with large blocks of text, and I realized after writing the summary that it is long for my liking, and I would appreciate it if someone would make a sound instead of like blocks of text to read in this case. So I'm making it for people who might like this more than reading. So let's get into it. We have this epic here that I've been working on, which is a proof of concept that we can use dedicated tooling for .com hosted runners. The reason why we want to do this is because um, hosted runners um, is quite reliable. The way we deploy things, we have the blue-green deployments, zero downtime. It's working for GitLab.com, so it's perfect. However, the maintenance of these runners is not very pleasant. The deployment of new shards, the scaling of new shards is not very pleasant. It's not a pleasant process, so we need to fix that. Similarly, Dedicated has got very beautiful set of tooling, very nice in the maintainability side of things. However, um, because it depends on a tool called Grit, that tool doesn't support blue-green deployments yet. It doesn't support a deployment that is zero downtime, and Dedicated doesn't really care about that at the moment. They have maintenance windows, so this is for them is not a requirement. As you can see, there's a downside for using each of these two deployment methods. So this proof of concept is hopefully highlighting what's needed in all of the toolings to get us where we want to get eventually, and have like a standard way of deploying between the different offerings. So SaaS runners and then dedicated runners, and in the future sales runners. So what did we do in this proof of concept? We forked Transistor into Transistor for -com. It's another repository. The hope was to have a green pipeline in here, but we didn't get to that point, which is fine because that was not really the goal. We created a GCP directory similar to that the AWS directory. So let me actually show you that. We have an AWS directory here. This exists in the current tooling for Dedicated, and we didn't touch that as part of this proof of concept. The goal is to create a GCP directory similar to that and attempt to make a deployment. So we decided to make use of grid scenarios. What is grid scenarios? Grid scenarios are Grid's recommended way of deploying runners. If you would like to know more about grid scenarios, you can go to grid docs scenarios, and you can see this file here. Yeah, so consult this file for how to execute a scenario. That was not straightforward, but we managed to have a successful manual deployment out of that, which was really good. So the basis here was one file that made use of Git repo, got scenarios, Google Linux. Sorry, I had to take a little break. So we are back, and yeah, have a look at the scenarios. Google Linux in here, which is the files that we basically bring in Terraform when we source it like this. And all we need to define here is literally just basics, the name of the runner manager, which instance it's going to communicate with, and the runner token. The runner token is a sensitive variable, so we don't really save it in Git, of course. So that is passed during the manual deployment and can be automated with the automated deployment. So going back to what we did here, after having a successful deployment, we just restructured the scenario into subdirectories so that we would have like the standard Terraform structure that you would expect. So for example, if I look in here, you can see outputs, providers, variables, etc. And then we move the Terraform state from being saved locally to a remote bucket. I thought Git would take care of that, but it didn't. So that was another step to manually do. Maybe that can be some feedback for the Git team. We can give them that feedback. The last thing we did was attempting to feed a tenant definition into the GCP definitions that we created. And that is done in dedicated through the tenant control tool. Now up to this point, I didn't really have to do anything with tenant control apart from actually just using it. Like I never had to look at the code or like understand what's happening underneath tenant control. So now that I did, I realized how much work needed to be done on that tool before we could have used it for GCP. So when I realized that, I realized that the hands-on approach for this proof of concept would not be, it's not attainable for me to reach the state that I would want to reach with the proof of concept, given the scope and the time restriction. So once I understood that, I realized that all of the issues that I created in hopes of doing them, actually executing them, I just cancelled all of them because I realized that that would not be the case. But we came out with some interesting learning lessons. So what did we learn? Transistor cannot work in isolation. It works with the rest of dedicated tools, including the tenant control, which is one of the tools that it works with. So as you can see in the beginning of this proof of concept, I thought let's scope this to changes within transistor. And then I realized as I worked through the different things that needed to be changed, that tenant control had to be changed as well. So that was something I didn't know before this proof of concept. The other thing is, of course, I learned the scope of how much work needed to be done. So for example, tenant control supports a multi-cloud setup, but only for instrumenter. It doesn't do the same for runner. So this was the work of Andrew Newdigate, and we basically need to do the same effort for runner to support a multi-cloud system. So we only now support AWS, of course. The third thing that I realized was that dedicated on GCP, I cannot click that link because it's confidential. I'm not sure where I'm posting this video and if people who are watching have access to it. So dedicated on GCP is not currently, it's work in progress, and dedicated runner is not part of this epic. Additionally, the runner team on dedicated in dedicated do not seem to have any plans to prioritize GCP in the upcoming quarters. I've checked the Q2 and the Q3 epics, and if we were to negotiate maybe this with the team, maybe we have a common goal there, I'm not sure, but it doesn't look like it's on the roadmap at the moment for dedicated to support GCP for runners, at least not at the moment. I think we are, the goal is to go to GA from beta for AWS, so I'm not sure how does this timeline align with cells and other things that might need this work to be actually done in a specific time frame. Okay, on to Gret. Gret has some downsides. It needs to mature a little bit before we can eventually use it for .com and for cells. So one of the biggest concerns is that at this moment Gret does not support a blue-green deployment, which is needed for a zero downtime kind of deployment. Now this is a functionality we have on .com, so when we transition we definitely don't want to lose any functionalities we want to add, so this is not negotiable. And the good news is Gret does promise to deliver that eventually, so it's on the roadmap. However, it's not clear when, so that is to be noted. This is a reference to the comment that mentions this text here. The other thing is Gret doesn't have additional monitoring, so it doesn't provide any monitoring besides the embedded Prometheus metrics, and that is not enough for GitLab.com. It's not probably not enough for cells. So, and again, is another thing that we are going to need to figure out. And the last thing is Gret on GCP is currently experimental. This is just a note, and everything else is not ready, so I don't expect Gret to be ready either, so that's just a note. And if you want to follow up on this, like follow the progress on this, you can see this epic. The recommendations. Okay, so to add support for GCP in Transistor, we would ideally have an effort similar to the beta phase effort that we carried out back in December last year. Some of the foundation in that epic was laid out, so Transistor didn't exist before the epic, and when we now come to add GCP support, we are not creating a new Transistor, we're just adding to it. So keeping that in mind while I'm recommending the number of engineers that I would like to see working on the future epic. So for the beta phase we had 5 engineers assigned. We had 3 dedicated team members, maybe not full-time, I think 2 were full-time and 1 was not, and we had 2 SREs, keeping in mind that was a holiday season, so I think that was also another factor there why we had 5 people. So we had a tight timeline for delivering the beta phase, and 5 engineers made sense. So just keeping in mind that if we don't have that same number of people working, I don't expect us to like finish things under a month or 2 months. So also keeping that in mind. The other thing is we had 2 engineers developing Gret, and that was really key for the beta phase because we were providing real-time feedback to Grit, and Grit was fixing bugs um, or shipping features as we were providing that feedback to them, and that was really valuable for the development of Grit. So they needed that. They needed someone to help them see where to go, and Dedicated gave them that at the time. And I hope that for the GCP part we would also do the same. So ideally, I would recommend the following headcount for Grit: 1 to 2 engineers to support from the runners team, and for Transistor at least 2 engineers, if not 4. So maybe we can go for 3, which is like a middle ground. And for monitoring, it would be really nice if we can have 1 engineer who would be dedicated for that. And hopefully it would also be a person who is knowledgeable on how we are doing this for cells. So yeah, well, I hope you found this video helpful. Please leave me any feedback you want directly on Slack or on the Epic. Feel free to reach out, even schedule time with me if you think that would be valuable. Thank you so much for watching. I hope that was helpful. Thank you.